Hello everyone, this is Hemadri working as assistant professor in the Department of Mechanical Engineering in RMK College of Engineering and Technology. So today I am going to discuss about introduction to engineering metallurgy and then solid solutions and types of solid solutions. So these contents we can see one by one. So first we will see the course objectives. What are all the course objectives? So in engineering metallurgy, we are going to discuss about various constitutions of alloys and phase diagrams and ion carbon equilibrium diagram, and to impart knowledge about the heat treatment process and applications, and we will discuss about the properties and applications of various ferrous and non-ferrous metals, and understand the properties of non-metallic materials and applications, and finally to test the materials under various loads and select the suitable material for different engineering applications. So now we will see the course outcomes. So after completing this course, students will be able to explain about various alloy systems with respect to invariant reaction, and they will classify the heat treatment process and its significance, and they will discuss about ferrous and non-ferrous metals and with its applications, and students will explain the non-metallic materials and its applications, and they will compute the material properties by various material testing, and finally they can select the materials for specific requirements after completing this course. So now introduction to engineering materials. So first we will see the classification. So engineering materials, majorly it is classifying into two types, metals and non-metals. So under the metals, again we have the ferrous and non-ferrous metals. So in ferrous metals, the ion is the basic element in the ferrous metals. So that's why we can call it as a ferrous metals. In non-ferrous metals, there should not be ion, so remaining elements will be there like copper, aluminum, bronze, so all these things will be there. So this is called non-ferrous alloys. So now coming to non-metal metals, under the non-metals we have the polymers. So polymers, again it will have the subclassification into thermoplastic and thermosetting. So in thermoplastic, again we can reuse the thermoplastic materials. So once you can make some products, again we can reheat up to some temperature and you can remold into different shapes. In thermosetting, it is not possible. So once you can make some products, it is not possible for reuse. So examples here we have given: phenol formaldehyde, polyesters, bakelite, all these things. And coming to ceramics, so ceramics it will have the two types, natural and advanced ceramics. So in ceramics, majorly it will have the high temperature resistance. So that's why we can call it as a ceramics. So these are all the examples: abrasives, glass, cement, or natural ceramics. In advanced ceramics, we have the alumina, silicon carbide, all are the advanced ceramics. So now we can see the metallurgy. What is meant by metallurgy? So metallurgy means we have to study the various materials, properties and applications. So it is a field of science and technology of the metals. So the metallurgy, it is classified into three types. First one is process metallurgy. In process metallurgy, we can take the metals from ores and we can apply some chemicals, we do the refining, and we can combine different metals, we can make the alloys. In physical metallurgy, we can manufacture the products from the various alloys, and we study the various physical, mechanical and chemical properties. So this is called physical metallurgy. And mechanical metallurgy, we can apply the various forces on the materials and we see how the material is behaving and how it is responding. So this is called mechanical metallurgy. So here we can perform the various tests like tensile test, compression test, impact test, hardness test, and we will find the properties of the materials. So this is called mechanical metallurgy. So now we will see the solid solution. What is meant by solid solution? So the solid solution is, it is a combination of two or more metals combining, we can make the solid solution. So in this solution, which element it is presenting in larger volume, we can call it as a solvent, and another element we can call it as a solute. So here the solvent and solute, we can call it as a solution. So example, in liquid solution means, we can take some example. So the sugar is dissolving in the water. So here we can take glass of water, we can add some 2 cups of sugars. So here the sugar is very less amount, so 2 spoons we are adding. So glass water is there, so here the water quantity is high. So here water is solvent, sugar is solute. So this mixture we can call it as a liquid solution. So now in solid solution, we can take the two metals or two elements and we can form the solution. We can call it as a solid solution. So here the solute atoms, it will be replacing the solvent atoms in a crystal structure. This is called solid solution. So the crystal structure, it will not change, it will be of any one element. So this is called solid solution. So here we have the two types of solid solution: substitutional solid solution and interstitial solid solution. So here substitutional solid solution, again we can classify the into two types: ordered substitutional solid solution and disordered substitutional solid solution. In ordered solid solution, the solute atoms will replacing the solvent atoms in a definite order. So this is called ordered solid solution. Coming to disordered, here the solute atoms, it will occupy the solvent atoms in any random manner. This is called disordered solid solution. So this is the difference. So here one example I have given. So copper atoms, we can take it as a solute. So these are all the copper atoms, and solvent are the nickel atoms. So the copper atoms, it will replacing the nickel atoms in a crystal structure. So the crystal structure, it should not change, it will be of any one element, nickel or copper crystal structure. So now in disordered, it is occupying in different, randomly it is occupying the solute atoms. Now we can see the ordered, so it is in a definite order. So all copper atoms, it is occupying in a definite order. So these are all the nickel atoms. So it is the crystal structure is FCC crystal structure. So without disturbing the crystal structure, the solute atoms will replace the solvent atoms in a crystal structure. So this is called substitutional solid solutions. Now we can see the interstitial solid solution. In interstitial solid solution, the solute atoms, it will occupy the voids or spaces in the crystal structure. So these are all the solvent atoms. So the solute atoms, it will occupy the gap or voids in a crystal structure. So this is called interstitial solid solution. So here the solvent atom and solute atom, the atomic diameter is very large difference. So example is ion. So ion is the solvent atoms and carbon is the solute atoms. So the carbon, it is occupying the void spaces in a crystal structure in the ion. So this is called interstitial solid solution. So it will enter in one of the holes or interstices between the solvent atoms. So this is called interstitial solid solution. Now next one is intermetallic compounds. So in intermetallic compounds, so when it will form means some of the elements it will have strongly it is in metallic and it will combine with weak metallic materials and it will form the intermetallic compounds. So example is this magnesium and tin. So this antimony, it is having the strong metallic element. It will form the combination with magnesium, we can form the intermetallic compounds like a magnesium tin, magnesium lead, like this. So it will have generally the melting point also very high compared to the parent metal. So this is about intermetallic compounds and the interstitial compounds. So in interstitial compounds, so it is having different from the interstitial solid solution. So in interstitial solid solution, the solute atoms, it is not in regular pattern, randomly it will occupy in the solvent atoms. In interstitial compounds, it is a regular pattern. So this is called interstitial compounds. Now electron compounds. So next is electron compounds. So when it will form means, so you can take the two metals, so it will have the different valency electrons. So then only the compound we can make it as a electron compound, like copper and aluminum and copper zinc, nickel aluminum, like this. So this is about electron compounds. So now we have discussed about what is the introduction to metallurgy and what are the classification of materials and solid solution and types of solid solution. Thank you.